Now, while we're here, let's take a look at an example. If it's not just x at the top, okay? So this is something new. This isn't in your notes. If I'm going from -5, remember that it doesn't matter what number that is, just as long as it's a number, to let's do x squared, and my function is w squared minus 5w dw. Some of you are probably like, why did you write w's? Because I said at the beginning, this letter does not matter. They use t's most of the time. They can use w, they can use q, they can use any letter they want except for x. So that's why they use a different letter. Okay? So if I want to find the derivative of this, alright, same rule, I take this and plug it in. So I got w squared, I'm going to plug in x squared squared minus 5w, I'm going to write 5x squared. I just replaced all my w's with x squareds. When this is not just x, you got to do a chain rule kicker. So I'm going to multiply all of this by, what's the derivative of x squared? 2x. So there's your derivative now. Okay? So when this is not just x, you got to do a chain rule kicker. Okay? We're really doing a chain rule kicker when it is x2, but what's the derivative of x? 1. So we're multiplying by 1. Reason behind this. Alright? Let's plug in. Let's find the antiderivative of this. We'll go through all the steps. I'll save this for Monday. Okay? So we have chain rule kicker. Alright, so now let's use the ideas that we just talked about to answer the question below. When is g increasing or decreasing? So I hope by now, as soon as you see one of those two words, you know I got to find the derivative and make a sign chart. So I got to find the derivative of g. What is g? What is g? G is an accumulation function. Got to get used to seeing that and recognizing it right away. Okay? So g prime would be the derivative of this. The derivative of that from 0 to x. All I do, plug in x. You don't have to find the derivative of this, you're just plugging it in. So it's not write this, then find the derivative, it's just plug it in. Okay? So increasing, decreasing, sign chart. Sign chart for g prime. What are the zeros of this? X squared equals, add over 4, x equals plus or minus 2. Some of you still forget the plus or minus. Another thing that a lot of you did on the last test, you wrote 0 all the time for 0. 0 is not always a 0. Now fill it in, alright? To the left, this is always going to be positive. This is always going to be positive. So we got a big positive minus 4, plug in 0, negative, and positive. So g is increasing from negative infinity to negative 2, and 2 to infinity is decreasing from negative 2 to 2. Very easy with the sign chart and the algebra. They're basically testing, do you know how to find the derivative of this? What does this all mean? How would you describe in words what it means when g is increasing? Remember, g is an accumulation function. So, g is the area under this curve. So, from negative infinity to negative 2 and 2 to infinity, during that interval, the area under this is increasing. That's what g is. G is the area under this curve. From 0 to an x value. So if I'm going from 0 to negative 10, that would be increasing because I'm in this area. If I'm going from 0 to 1, the area would be decreasing. If I'm going from 0 to 52, 52 somewhere down here. That would be increasing. Okay? G is the area under the curve. So here the area is decreasing, here the area is increasing, here the area is increasing. We'll look at the graph next week.